Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking Tableau for sponsoring today's event. Tableau is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Exaptive, Microsoft, Hortonworks, Oracle, IBM, and Teradata, to name just a few. Past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled, How Data Can Protect You from Cognitive Bias. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have one panelist that I'll introduce in just a minute. There'll be a 10 to 15 minute question and answer period following the presentation. And this event is being recorded and will be available on datasciencecentral.com later today following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. So I'm very pleased to introduce today's speaker, Dr. Jock Mackinlay with Tableau. Jock Mackinlay is Tableau Software's Vice President of Visual Analysis Research and Design. At Stanford University, he pioneered automatic design of graphical presentations of relational information. He joined Xerox PARC in 1986, where he collaborated with the User Interface Research Group to develop many novel applications of computer graphics for information access, coining the term information visualization. Much of the fruits of that research can be seen in his book, Reading in Information Visualization, Using Vision to Think, and Jock has a PhD in computer science from Stanford University. Thanks for being with us today, Jock. We're looking forward to your presentation. The smarter you are, the stronger your cognitive bias. Data is a proven way to protect yourself from cognitive bias and can even augment your intelligence. So in today's Data Science Central webinar, we'll educate and entertain you with lessons about cognitive bias and how data, when used correctly, can improve your decisions. It'll also explore how to systematically analyze data using your visual system, which results in better decisions. So Jock, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Bill. So we live in a world of increasing data. Computers are great tools for collecting, storing, and processing data. The Internet of Things is coming, where every device will collect data. Have you wondered how you can take advantage of this data? How it's useful to people? How it's useful to you? Hi, I'm going to tell you today about cognitive bias and how we all suffer from it unconsciously. I'll then spend the bulk of the talk giving you concrete tips on how you can use data to protect yourself from your unconscious bias. And I want to start by telling you how capable people are, because that's actually where the cognitive bias comes from. You probably instantly saw this lion in the grass. That's because our remote ancestors, if they wouldn't have survived and you wouldn't be here today. It's because of evolution that we have very capable brains, capable ability to recognize things in our environment. In fact, evolution has significantly increased our ability to do that. I'm showing here a picture of a person working with a map. So a map is a visual representation of the world that we can understand for the world. And in fact, we know how to draw maps using a Mercator projection in this case, where if you draw the line on the map, it can tell you the direction you need to head in the world to get somewhere. It's an amazing capability of human beings. We're very capable creatures. We can think, and we're very, very smart. But along with that, along with our ability to have intuition and creativity, comes the fact that we have bias that just happens automatically. One of the biggest biases that we have, particularly with respect to data, is confirmation bias, where we typically go off looking for data to confirm whatever intuition we have. And what you need to understand is that I'm not an expert on cognitive bias. I'm a psychologist. I'm a computer scientist. But the literature, there's a lot of different biases that we have understood, and that people seem to have, and they break down into a couple of different types, which I'll tell you about in a moment. But really, to first order, we're like the little man on the top of an elephant. If the elephant decides to go left or right, confirmation bias will decide that we wanted to go that way too. In other words, we have a lot of unconscious aspects to us that control our ability to make decisions. There are three main kinds of bias. There's the big category is decision-making bias, where it involves us making decisions, our beliefs, and our behavior, of which confirmation bias is an example. There are also social biases, like the self-serving bias. This is one where we'll attribute sort of positive qualities to ourselves and negative qualities to others, and that will affect how we interpret the world. And then there are also memory errors that occur. Hindsight bias is an example, where we will not take into account that something was less likely to happen in the past. When we look back, we'll see that, we'll believe that it was more likely to happen. Now, I can give you, even over a webinar, a little bit of a feeling for what a bias might feel like, with a very famous example that was used to study bias. It goes like this. Imagine that you have a baseball and a bat, and that together they cost $1.10. And then I tell you that the bat costs $1 more than the ball, and ask you how much does the ball cost. Most likely, most of the people I'm talking to leap to the answer that the ball costs 10 cents. But if you sit for a moment and do the calculation, you'll realize that the ball costs 5 cents, because when you add the dollar to it, you end up with the $1.10 for the total. This particular example is a form of priming. I primed you to think of 10 cents. And it also illustrates the value of data. You can see that by doing a data calculation, we can come up with the right answer. We can discover that if we thought it was 10 cents, we were wrong, and we can come up with the correct answer. However, there's a problem about this example, which is true for everyone, which is that humans aren't very good at doing mental math. So, for example, if I give you this 2 by 2 multiplication problem and asked you to work this problem in your head, you would be challenged because humans have limited short-term memory, and it is difficult for us to hold in our heads the partial results of this problem. Obviously, a bigger multiplication problem would be even more difficult. Now, if instead I told you could work the problem with pencil and paper, you would find it much easier to work the problem because you can use the paper to hold the partial results to the answer. In fact, if you study people, you'll find out that they can work it many times faster using pencil and paper rather than working the problem in your head. Now, this is exactly why we use the external world to work problems, and why that's the key solution to using data to help you with your cognitive bias of one type or another. Now, back in the research lab, we studied many people who work with data to solve their problems, to make their decisions. And we found that there's a very standard pattern people go through, which we now call the cycle of visual analysis, shown here. At the top of the cycle is a task where data is relevant to the task. And because of cognitive bias, I think almost every task data is relevant to it. And the first step in the cycle is to go get the data for the task. And then you choose a visual mapping for the data because it's much easier for people to work with data when it's in visual form. You look at the graphical view of your data and then develop some insight and go off and act on it. This is the basic cycle of work when people are working with data. However, the reality of it when you study people is that it's actually a very complex backtracking process. You start with the task, you go off and get the data, you choose a visual mapping to look at your data, you look at the view, and typically the view isn't actually helping you answer your question or come to a decision. So you backtrack. You'll go back to choosing a different visual mapping to look at. Sometimes when you look at the view, you realize you don't actually have the right data, so you need to go get additional data. So you might backtrack to that step. Sometimes you realize that you didn't have the right task to start with, so you might change your task. And what I find really interesting is that even if you get to an insight, the first thing you have to do, because we're human, is almost always, once you have an insight, is to go off and tell other people. So you'll notice that in the upper left, under act, I put parentheses share. What you need to do is go share your insight with other people. And to do this effectively, you also end up backtracking. You typically need additional views of your data, and sometimes you even need additional data to share it with other people. So this is the rich, complex task that we need to support to help protect people from their cognitive bias. And I'm going to give you an example of the richness of this task. And I like to introduce this example this way. What happens when you have one of these and it meets one of these? If you're very, very lucky, you get one of these. And of course, this is what's called the miracle on the Hudson, when a U.S. Airways plane hit a flock of birds and did an emergency landing on the Hudson, and all the passengers were saved. And when this happened, at Tableau, somebody went off and discovered that the Federal Aviation Agency had a wildlife strike mitigation working group, and they were collecting reports from pilots about wildlife strikes. And in fact, this is the upper left-hand corner of that data set that they're collecting. And what I'm trying to do is induce you a natural question about an analytical question to give you a feeling for how you would use data. The intuition is that it might not be safe to fly because we just heard about the miracle on the Hudson, and here's some data to find out if we're right or wrong. It's very typical data. In the left-hand column, you can see the dates. Data almost always has dates. Then there are string columns like airport and species, and then there are quantitative columns like height and speed. And the problem is, of course, that unless you're an expert in databases, this is not easy data to process. There's a lot of it, and you have to write queries. This is data in an Access database to be able to do any sort of analytical work. Instead, what we need is a graphical tool that can allow us to quickly explore this data. And so I'm going to demo how you would do that using Tableau. So let me fire up Tableau for you so that you can get a feeling for how to work with the data. So this is the same data that I was showing you a moment ago. On the left here are the various columns. At the top are information about the aircraft, about the airport. Here's amount of damage. Down here, there's flight date, state. There's even information at the bottom about the species of the wildlife struck. And then there are quantitative columns like cost, feet above ground, and then down at the bottom here, you can see number of strikes. Now, to explore this data, a natural thing to do is to drag out fields. So here I'll drag out the number of strikes and put it on the column shelf. And you can see that there's on the tooltip, it says that there's 167 reports to the FAA about wildlife strikes from pilots. And for this particular analytical question, a natural field to explore is the amount of damage. So I can drag the amount of damage and drop it on the row shelf, breaking that bar apart. And I can also drag the amount of damage and drop it on the color shelf. And what we can see here is that there's a 45,000 reports where the amount of damage was null. That would be because the pilot hadn't entered any value. It's empty. There's 107,000 where there's no damage, none reported. We have 7,000, almost 8,000 minor, 2,000 medium, 3,000 substantial, and 130 destroyed. Now, what often happens when you start exploring data like this is other questions can pop in your head. So, for example, here's the cost field. So it's a natural question to ask, what's the relationship between the number of strikes and the cost? And you can do that, you can explore that very easily in Tableau by dropping total cost and building what Tufte calls a small multiple view. And you don't have to know any statistics at all to see that there's inverse correlation. Inverse correlation means this is dropping while this is going up. It's very easy for people to see that, even if they don't know what the fancy term means. And it's not surprising that the cost is going up because this is the amount of damage. But what was a little surprising when I did this the first time after the miracle on the Hudson was the size of this orange bar. As you can see here, that's almost $500 million in damage, really a lot, completely justifying the FAA having a wildlife strike mitigation working group. But now, the key thing for this talk is if I were trying to show that it were safe to fly, I might stop at this point. But the reality of it is you should be inquisitive. You should explore. I don't think I've completely nailed the hypothesis that it's safe to fly, or because I've certainly not shown that it's dangerous to fly. If you think about it, there are additional factors that enter into this problem. For example, it may be more dangerous in different parts of the country. I live in Seattle, so Seattle's a bird migratory zone. Or maybe the trends are getting worse because I hadn't heard about this issue until the miracle on the Hudson. Maybe the trends are getting worse. And so you need to really be able to use data effectively to protect yourself from cognitive bias. You need to be able to explore it deeply and quickly. And Tableau, this is pretty easy. I can keep this view and go off and explore the where and when questions I was just talking about. And so the where question you can start fairly easily by taking origin state here. And if I drop it on the detailed shelf, I'll get a map. And then I can pick up the number of strikes and drop it on the color shelf. And now here we have a nice filled map of the data. And you can see that there's a lot of bird strikes that were reported from California, from Texas, and from Florida. And that sort of makes sense because these are very populous states. And so you expect a lot of bird strikes. Now, if you peer at this, you'll see a slight darkening of green here for Colorado, which is not a super populous state. Now, what I'll tell you as an expert is that color is not a great way to show quantitative data. Better would be to use size, and so I can pick up the number and drop it on size. And here we can clearly see by the mark on Colorado that there are a lot of bird strikes being reported from there. And then if you ponder it for a moment, you'll realize that there's lots of commercial flights that are stopping in Colorado on the movement from east to west. And up here in Washington State, where I live, the mark is fairly small, so it doesn't seem like that I have to worry that much about bird strikes in Washington State. Anyway, we could dive deeper into this data here, but what I want to move on to is the when question. And so I can go do that by starting another sheet and start over again, just like before, and drop out the number of strikes. And in this case, I can get flight date. and I can drop it on the column shelf. And I instantly get this trend line. Now, when you see a view like this, your visual system is very capable. I was talking about how capable people are. And you can see instantly two aspects to this trend line. One aspect is this drop at the end, and the other aspect is this increase over time. Now, when you see these things visually, you form hypotheses to try and figure out what's causing that. So when I ask people in an audience why there's this big drop at the end, people typically get that it's caused by incomplete data. This is data aggregated up to the year. And you can easily confirm that by drilling down to quarter and then going down to the month level. And what you can see here is there's more bird strikes reported in the summer months rather than the winter months. Here's 1990. And if I scroll to the right, you can see that the last year's incomplete. And so we can see that this drop here is caused by an incomplete year, and we can use the tooltip. We have an ability to filter out data, so I can exclude that. Now there's this huge increase over 2 decades. And then when I ask audiences about why that is, we get multiple hypotheses. And this is a very good idea. When you're working with data, it is good to come up with multiple hypotheses. The one I almost always hear is that there's more reporting. Then I hear that there's more flights as another hypothesis for causing this increase. And then when I probe people, I often hear a really funny one, which is that there might be more birds. I don't have a bird population database, so I don't have a way of exploring that. But it is a possibility, and it is important to explore these different hypotheses. So let's start with the more reporting one. That one's pretty easy to explore because it's what I've already done before. I can drag out the amount of damage and drop it on the color shelf. And what we can see is the nulls have been going up over the 2-decade period. The nones have been going up as well. But the minor, medium, substantial, and destroyed are staying flat. I think this is evidence confirming the more reporting hypothesis, because when it mattered, the reporting has stayed flat. But when it hasn't mattered, that's what's been going up over time, as pilots, I think, have become more aware about the need to report bird strikes. In particular, notice this huge jump here between 2008 and 2009 in the none reporting. Well, what I remember is that was when the miracle on the Hudson occurred, and there was all this press about bird strikes, and I think that that's what caused pilots to increase the amount of reporting. So, but we can also go explore the more flight one, and we should, because it's not enough to find evidence supporting one hypothesis. You also need to find evidence that explore other hypotheses as well to avoid confirmation bias. And so I can do that here. Here's another database that I've developed, or that comes from the FAA. It's a database about on-time arrival statistics that they've been collecting, and it has what you'd expect. There's information about destination and origin, flight date, the flight number, wheels on ground, tail number, and then a bunch of quantitative data like arrival delay and on-time arrival statistics and whatnot. And so you can drag out here the number of flights like before, and you can get flight date. And, oh, by the way, before I do that, notice this is a slightly larger database. This is 157 million rows. A few years ago, I would have had to put this data into a hot database box. But now a Tableau data engine runs over this level of data pretty quickly. So you'll notice that when I drag out flight data and drop it here, there's a slight delay, but then I get the trend line. Now, we can go explore this, but we know the drop here is, in fact, incomplete final year, so we can get rid of that. We can also see additional properties in this data. Here's a drop in 2000 to 2001, or 2001 to 2002. That's caused by 9/11. And here's a drop starting in 2007, which is the recession. And now we can explore our hypothesis here by dragging out number of strikes and comparing these two against each other. And what we can see over a 2-decade period is that the number of strikes is going up, But for the first decade, the number of flights was flat, so we don't see strong correlation between those two, even though there was this increase here that would relate with that one. So that's my demo, quick demo. I could go on some more, but I want to go back to cognitive bias. And the first thing that I want to tell you is that kind of exploratory environment does lead to insights that you can act on very quickly. But the real value of an environment like that is that it can save you time. In other words, you can work through the data and all the different hypotheses very, very quickly. And time is the really important commodity for people. And so it's hugely valuable for people, and it's quite exciting for people. And I also think it makes us better at our cognition and our decision making, because if you can work through your data that quickly, you can stay in the train of your thought and work on that. Now, the outline for the rest of the talk is going to focus on that from the three different points of view of the cycle of visual analysis that I described about before. I'm first going to talk about this from the data point of view, then I'm going to talk about it from the view point of view, and finally I'm going to talk about it from the sharing point of view. And so for the data point of view, I'm going to start with a very famous example of a cognitive bias, which is called the Wason card selection task. And it goes like this. If a card shows an even number, there's a rule. If a card shows an even number, then the opposite face is red. And your task is to determine whether that rule is being followed or not. And so here's the problem. I'm showing you 4 cards. And the question is, which 2 cards should you turn over to test the rule? So I'm going to give you a moment to think about that. And then the reality of the answer is you need to turn the following 2 cards over. Now this is a difficult task for people. Turning the 8 card over is very straightforward, because if the back side of the 8 card were red, then the rule would be broken. But what's difficult for people is that you also need to go look for evidence that disconfirms the rule. And that's why turning the blue card over is the necessary thing, because if the opposite side of the blue card is red, if it is even, then it would be breaking the rule. Whereas turning the red card over doesn't matter, because it doesn't matter what's on either side of the red card. And so that's why this is very difficult for people to realize they need to turn over the blue card. And this comes up all the time. Here's a very amusing example from the XKCD comic strip, where the little guy is looking at 3 different views: one of user sites, one of Martha Stewart Living, and one of consumers of furry pornography. And the key thing here is that all 3 of these views relate to the fact that there's a standard distribution of population in the United States. And so you need to go off and realize that there's additional data involved in here, rather than thinking there's some correlation between these 3 views. And I have another example of the same thing, which we've been very interested in the data about minimum wage in the United States. And here's the standard plot of minimum wage, which you can see started in 1939, and then that has gone up to a little bit of plus $7, which is the value today. But there's a significant piece of data missing from this particular view that you need to have to understand the minimum wage. And that's the data of inflation adjustment, what the actual value of goods is over time. And as the orange line that's shown here shows you the impact of inflation on the minimum wage. And as you can see, from the moment minimum wage is put at a level, the inflation drops the value of those dollars over time, and that the $7 that we have slightly plus $7 minimum wage we have today is substantially less in terms of buying power than the historical peaks back in the 70s. And so when you're working with data, you'll always have to ask, is there additional data that's relevant to your task? And that's a key data question about working with data effectively so that it can protect you from your cognitive bias. Next, I'm going to turn to the view area. And the reason I show this picture of tools is that the key thing here is that you really need to understand your tools really well for working with data effectively to be able to make your decisions. And I'm going to use another very famous example, which is called Anscombe's Quartet. Anscombe was a statistician, and he very carefully crafted this small data example for you. So here you have 4 different samples of data of some event, and there's a set of different rows for each of them. And the first thing I want to say is this is another example of why we need to use visual techniques to work with data, because even this very small data set is actually hard for humans to understand. Now, if you have statistics background, which I know many people in the audience here do, you might think that statistics would be the way to separate out the properties of these 4 samples. But Anscombe was very clever. He designed these examples so that all the standard statistics are exactly the same for them, or very close to the same for them. So we have the average of X, the variance of X, the average of Y, the variance of Y, all basically the same. The correlations between X and Y are basically the same, and the linear regression line for X and Y is basically the same. Now, you can instantly see the difference between these samples when you make them visuals, which is actually what John Tukey in his exploratory data analysis made the argument to the statistics community. It's often a very good idea to put your data into visual form to help you do your work, in addition to having the statistics tools. They're quite useful, but the visual tools are also useful as well. So here are 4 samples drawn visually, and you can instantly see that even though their averages, their correlations, and their linear regressions are the same, they really are quite different data sets when you compare them visually against each other. And so visual tools are quite useful for working with data. So I'm going to take a moment and talk a little bit about effective ways to do that. One of the things to understand is that standard statistics, like averages, can be quite misleading. And so one of the things that we've done in our recent free product on the iPad is when you use an average in the category world, we'll show you an underlying distribution of it automatically. This will help people who don't understand the dangers of averages get a sense for it. So what we have here is a movie database where the dark line represents the average value, but we'll automatically put in a distributional view underneath, where, like, for example, down here under documentary, you can see instantly that there's an outlier that's pulling its average up, making it different. Even though its average is the same as comedy and horror, it's pulling it up because of the outlier. Now, I have another example, because I really want to give you a warning here. Recently, we had an intern who pulled some data from wine.com to look at. So I threw that data into Tableau. So what we got is 1 row for every different wine sold on wine.com. And the first thing that I did was generate this trend line. And when I looked at the trend line, I was very puzzled by it at first, and then suddenly realized that this line is showing the sum of current price of wine on wine.com. But that sum, the simplest aggregation you could imagine, is actually misleading for this data because, in fact, summing up the different wines on wine.com doesn't make any sense. Instead, what I should have done is just counted the number of wines on wine.com, which is this view that you can see here. It basically looks the same as the sum view, but in fact it represents just the different types of wines by age that wine.com had on the site. You can also see here the average price of wine with these amazing spikes. And again, aggregation, in this case average, is hiding some information. And you can drill down now into different types of wine to understand what those spikes are. So the red line here shows that the red wines go back to 1950, and that the really old red wines are very expensive. And so that explains the spikes as well. Now, I see I have about 10 minutes before we should get to Q&A, so let me move through some examples more quickly. There's a famous one in this great book by Daryl Huff called How to Lie with Statistics. It has to do with aspect ratios and including zeros and plots. It goes like this. Here's a nice little trend line of billions of dollars, I guess, of federal spending or something like that over time. And the little guy drawn behind here looks very, very calm. A very common thing that people do is because there's all this empty space at the bottom, is to trim off the bottom. And in this aspect ratio, the guy still looks very, very calm. But then people stretch out the view, and the guy now looks alarmed. And this is a very common thing, and Daryl Huff is telling you, know your tools, that if the zero is not included and the aspect ratio is stretched, you might be getting an alarming view of some data that really, in fact, isn't very alarming. Now, I think there's a lot of nuance here that you need to know your tools really, really well. So here's an example of sunspot data. Sunspots, turns out, have an 11-year cycle, and here's the data plotted this way. You may not notice the 11-year cycle that well with this aspect ratio, but if you make a narrow aspect ratio, you can clearly see the 11-year cycle. But the interesting thing is if you switch the aspect ratio to the opposite form, you'll notice that at the bottoms here, there seems to be some sort of regular event on the minimum sum spots that's going down and going up on an even larger cycle. You can use aspect ratio as a way to explore your data. Now on the zero part, here's height and weight of baseball players plotted with zero included. This is probably not the best plot, or they're not the most exploratory plot. In fact, it's worthwhile to look at the data both ways. If I take out the zero, you can clearly see that one of the players is an outlier in terms of its height. He's up at 82. That's the dot, the most on the right. Here's another example. So here's daily stock trend against zero. Most times when we look at daily stock, we don't include the zero, but you can see this is IBM moving over time up and down. Most of the time, people look without the zero included because they're very interested in the relative movements of the stock up and down over time. But of course, this makes for a more alarming view, but you can be more sophisticated about it. Now, often people look at two stocks against each other over time. Here's IBM and Microsoft. Here I've plotted the data without zero, and so you can see the relative movements of these prices, but it's actually can be hard to understand their absolute magnitudes against each other, which of course isn't really that relevant because the stock prices are different to each other. What people often do is, rather than putting the two curves on the same axis, they create a dual axis view. And then here's an example of the two prices on the dual axis view. But dual axes are a dangerous tool to use because it's very arbitrary for how you plot the two against each other. In this particular plot, notice that in February 2015 to April 2015, or actually just slightly less than that, it looks like the two stocks moved together, and then they moved again together from a little before June 2015 until into July. But that all depends on exactly how you correlate the two lines against each other. And in fact, it's very easy to find just two arbitrary trend lines against each other. I recommend this lovely site here, which is it's a site that just finds automatic correlations. Here we have the age of Miss America against murders in steam. So I can arbitrarily change this to change different correlations against each other. And then the final thing I want to say about this is that there are more principled ways of combining two lines together. And notice here that if I take the endpoints of these two lines and put them on top of each other, which is what I'm about to do with the next slide transition, you'll see that this particular view is pretty close to, given the current price of this chart, shows that there are moments of correlation given the current price that seem to be moving with respect to each other, and then other parts that are moving differently. So this is actually a slightly better view for comparing these two stock prices, because we're comparing them against a fixed date when they were at the same level. This is the difference from the close date at the current level. Now, my final category is sharing. And the thing about sharing that's very important is that, in fact, it is sharing that is the single thing that will help you use data most effectively to protect yourself from your cognitive bias. It is when you share your findings with somebody else, that, particularly your friends, where you're going to find out if your analysis of your data, if your potential decision is right or wrong. And so it's very important to explain not just your finding, but exactly how you got to your finding. And so I have an example here of a nice. It's just a really succinct example from the New York Times of how to do sharing well. So let me bring that up in the live view and show you how the example goes. So this is a standard kind of view that you will see on the web. This is running on the New York Times. It's got a little navigator here. And this was a story that they produced before the Copenhagen Climate Change Conference. And the first view is about the 2007 total emissions. And you can see here that there's 6 billion metric tons from the United States. We have various metric tons in Europe. And over here in China, we also have 6 billion metric tons. And there's a little navigator up here at the top, which you can use to move through the story about this. And so the New York Times is trying to explain a particular finding about what's going to happen at the Copenhagen conference. And the first thing they do is they bring up a line chart here that shows that over time, the metric tons for China has been climbing up and has just surpassed the metric tons for the United States. They also plot Europe and India for comparison values. Now, this is really interesting because the first point that they make, if you click on Next, is to switch from just raw metric tons to emissions per capita. In other words, China is a very big country, and so it's much lower than the United States in emissions per capita because it's a very populous country. And the United States is very high in emissions per capita. So New York Times here, in sharing their data with people, is helping people understand the properties of that. Then they switch to emissions per dollar. So United States has been, so China has been dropping in terms of its GDP because its GDP has been growing over time. It's above the United States from a GDP point of view, and the United States has been dropping slightly along with India and Europe. Then they talk about the Chinese proposal going into this conference in terms of the emissions per dollar. And as you can see from that point of view, the China proposal is dropping. That's because their GDP will continue to go up. At least that was the estimate in 2007, and actually it did. And then they switch to emissions in terms of raw metric tons, and they see that, and you can see that the implied Chinese proposal is just an increase in raw metric tons, which is going to be alarming for the world, anyone in the world who believes that emissions is actually relating to climate change problems. And then the final panel shows the United States proposal in terms of raw metric tons, and you can see instantly that there's these two relationships against each other. So this is an example of how to go about telling your story, where what you do is you include not just the finding, but also the steps of analysis leading up to the finding. So here are the steps of analysis for this one, and it's a very common thing that you'll need to do if you want to actually get people to help you understand whether your inference process is right or wrong. In other words, looking at the data normalized in different ways is very, very important, by capita, by GDP, and then explaining your finding is very important for doing that. So the basic lesson here is that what you want to do is you want to provide people with the raw data, and as well as the individual steps of your analysis. I see I need to finish up very quickly, so let me go through my final example really quickly. Here's an example from Tableau Public of this kind of sharing. There's this blog in Wisconsin about an investigative journalist blog, and they did a blog on Wisconsin milk production. And in this blog, they show that the orange line down here is that the total amount of milk production has been going up, even though the cow population in the green line has been dropping. They published this view on Tableau Public along with all of their raw data, and that was picked up by this economist, Mark Perry, who then added in additional data, a very good idea to look at additional data about the price of milk, which is the red line shown here. And so he said not only has the milk production been going up, but the price has been going down, which means that the Wisconsin dairy farmers have been doing a very effective job. So that brings me to my last slide. So in summary, what I'm recommending is that you should be inquisitive when you're working with data. You should know your tools, and you should share your findings with others, in particular because sharing your findings is precisely the way to protect yourself from your cognitive bias in your data analysis and actually find out if your data analysis is correct so that your decision is the correct one. So thank you very much, and I'm now ready for questions.
Well, Jock, thanks so much for that very excellent presentation. We'll get started with today's Q&A session. And I want to thank the audience for their participation. We've had a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. So during this Q&A session, I'll leave up this screen with contact information for Jock in the event that you'd like to contact him following today's webinar. So let's get started. Jock, there are several categories of questions that have come in, but since your presentation dealt principally with cognitive bias, let me start there. For example, a lot of us in the data world are not familiar with concepts of cognitive bias. Where can we go just to learn more about cognitive bias?
I think a really good place to start is the Wikipedia page on cognitive bias, and that'll lead you off to a bunch of other literature that you can explore. The key thing to understand is what I said before, which is that we all suffer from cognitive bias. It's unconscious for us, and that you need to protect yourself from it. But the Wikipedia page is really great. It lists a bunch of different kinds of biases, and also gives you a short history of the research in the area, which is completely ongoing. There are many psychologists studying different kinds of bias to this day.
Well, thank you. And do you have any advice for how we might avoid introducing cognitive bias in our hypotheses?
So I think that you're going to. I actually think that it's very important for people to understand that human intuition is very powerful, and the formation of hypotheses is in fact mostly driven by our intuition. Now, that our intuition can be deeply informed by working with data, and so working with data is actually an important part of it. But the actual hypothesis comes from intuitive leaps that people make, and if you do that, then the bias will come in regardless into your hypotheses. So the key thing is that after you have a hypothesis, the protection is through careful analysis, both of what you think the answer is and also other possible hypotheses by going through an analytical process like I tried to demo with the bird strike data. And that is really the form of protection. It's not the formation of the hypotheses where you can protect yourself. It's validating that hypothesis against others that is your protection.
Right. Well, I guess it would be too much to expect that the Tableau would prevent us from having bias, but I think there are ways that the Tableau can keep us out of trouble. There are a bunch of questions that have come in regarding Tableau and its operation. For example, when we go to design visualizations with Tableau, is there some inherent logic there that kind of keeps us out of trouble? For example, you said color is not a great way to show quantitative data. Is Tableau going to help me not do that?
Well, so that one's a good example of no, Tableau doesn't actually. Tableau, we want it to be a free-form exploration environment. So if we were to narrow, we were to become too protective, we wouldn't be letting you to explore. But what Tableau does have is a bunch of rules about best practices built into it. So back in the demo, you'll notice that I ended up with one time I ended up with a bar chart, and another time I ended up with a line chart. And that was because time was involved for the line chart. Now, you can use Tableau to turn it into a bar chart if you want, and that's completely appropriate. So we strike the balance between giving you a general exploration environment as well as trying to give you really good defaults to help you start working with your data. I believe actually the fundamental way to help people here is through letting it be very easy for them to explore their data. And this is actually why people without any statistics training can discover the fact that statistics may or may not be giving them the right answers, because the exploration process really can help people do that. And it's actually an active area of interest for us, which is how can we give people automatic advice but still let them very easily explore their data. In other words, it's the combination that we want to try and achieve.
Right. We wouldn't want to be overly bound, but did I correctly understand that if, for example, I put a time variable on one of the shelves, presumably the row shelf, that Tableau will start me off with a line graph, and I can force it then to do something different? Yeah. Okay. I can demo that if you want, but I think it's you got it completely clearly, so probably everyone did. So yeah, okay, good. And Tableau is only a very powerful assist tool to analysis, so it's not necessarily going to tell us what to put on the X and Y column, but it's going to help us make the best sense of that visually. Yeah, I'm a very strong believer in augmentation of humans, because I think humans are very intuitive and very skilled at doing analytical work, except for the issue of cognitive bias. Whereas the problem with completely automating this is that, first of all, there's huge combinatorics. Like, the computer can't know what data I'm interested in and what fields I want on the row and column shelf, what task I'm working on. And so if we have it trying to take too much control, it actually makes it very, very hard for a human to work with their data. I think that computers are most powerful in a supporting role. Right, I can understand that, and that's a good point. You know, there was a point in your demonstration where you loaded 157 million rows of data, and it was almost instantaneous. And the audience had two questions around that. One is, what type of help does Tableau give you in loading different types of data? And second of all, are you using a particularly powerful box, or is Tableau really that good to load 157 million lines that fast?
It's really that good. I can do that on a laptop. Now, of course, 157 million rows is small, given the amount. When I started this talk, I talked about the amount of data that's increasing. When you're dealing with large amounts of data with Tableau, the best thing to do is to live connect to a big hot box of one type or another, and as long as the exploration you do doesn't have to pull that much data, aggregated data, out of the database, then you can actually work with really large amounts of data. The other thing is there's two parts. So there's also there's a couple of issues around connecting to data, which was the other half of the question. One issue is that there's a lot of data still out there that needs cleaning of one type or another, and so Tableau is working on that. In the last couple of releases, we've been adding features to help people clean data. The more important one, though, is that it is almost always the case when you're working with data that you end up needing data from multiple sources. And in fact, this was a core part of this talk, which is I was trying to point out, even in the demo, I started out with just the strike data and ended up with the flight data. This comes up all the time, and so in real problems. And so it's the integration of data from multiple sources that is absolutely important for trying to answer questions. And so we try and make that. We're trying to make that very easy for people to do. You don't have to be an expert in databases, a database administrator, to be able to combine data together, and we're continuing to innovate in that area because that's the pattern that comes up. The data is coming up, is just burgeoning everywhere in many different sources, and it's the combination of to answer a particular question that comes up all the time.
Right. As a data scientist, I must say the example you gave of Anscombe's Quartet really was a lot of fun. Data looks so different, and yet obviously has the same statistical profile. So, the broader question is using data visualization for machine learning and other types of predictive analytics. Particularly where I say I've got a lot of variables and many of them are correlated together. Have you got any advice for visualizing lots of variables that may move together and trying to separate out those that are important?
I've got a couple of things. We definitely have people trained in statistics and machine learning who use Tableau, and they use the visualization, the visual analysis I demoed in two places in particular. The first place is at the beginning, which is that when you're trying to build up your statistics model or machine learning box, you can use Tableau to explore the data and figure out what parts of it you want to pay attention to, either for the model or as training for the machine learning box. And this rapid exploration is really important for that. The second one is after you've actually built your model or your machine learning box, and it might be proved quite useful for you. Like, for example, computers, are very good at processing lots of data, and you might have a machine learning box that's paying attention to streaming data, fraud detection, or something like that. You still need to tend your model or your box for you. You need to validate that it's working correctly, and Tableau is a great tool for doing that, for trying to understand what the behavior of the model or the box is. And secondly, there's always room for improvement. And so at that point, you can use Tableau to figure out how you might modify your statistical model or train up additional machine learning to support that. The two can work together. It's not like it's only the augmentation of human intellect or automatic, algorithms running in a prescriptive mode. They can work together very effectively, and my focus is on the human side, because I think humans, first of all, humans are paying for it. And second of all, they really care. And third of all, I think they're really, really capable. So.
Well, Jock, thank you. That was great answers to some really good questions. Now, for those of you that asked questions that weren't answered today, we'll be sending all the unanswered questions to Jock and the Tableau team so they can follow up with you after today's webinar. I have just a few quick announcements. If you would please mark your calendars for March 17th, that's just 2 days away, which is our next Data Science Central webinar, which is Hybrid Deployment for Analytical Data Warehouse, a case study sponsored by Teradata. Also, please remember that today's taping will be available for on-demand viewing later today and can be found on the homepage of Data Science Central in the Webinar tab located at the top of the page. Well, that brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again for Tableau for their sponsorship and our speaker today, Dr. Jock Mackinlay, for his insight into today's topic. My name is Bill Vorhies. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on March 17th. That's just 2 days away. Have a great day.